Non-aqueous titration is a method used in chemistry to determine the concentration of an unknown substance by reacting it with a known reagent in a solvent other than water. Unlike traditional titration methods that use water as a solvent, non-aqueous titration involves using organic or inorganic solvents to dissolve the substances being analyzed. Let's dive into the types of solvents of non-aqueous solvents. Aprotic solvents. Aprotic solvents are a class of solvents that do not contain easily exchangeable protons, H+ ions, and, therefore, cannot donate hydrogen ions. These solvents are often used in a wide range of chemical reactions and are particularly useful in facilitating reactions that involve strong bases or nucleophiles. They can stabilize ions and are commonly employed in many organic and inorganic reactions. Some examples of aprotic solvents include 1-dimethyl sulfoxide, DMSO. It is a highly polar aprotic solvent that is frequently used in various organic reactions and as a reaction medium for biochemical studies. 2-dimethylformamide, DMF. This is another highly polar aprotic solvent that is commonly used in organic synthesis, particularly for reactions involving organometallic compounds and various reagents. 3-acetonitrile. It is a widely used aprotic solvent in organic synthesis, especially in the pharmaceutical and fine chemical industries. It is also used in various analytical techniques such as high-performance liquid chromatography, HPLC. 4-tetrahydrofuran, THF. THF is a cyclic ether that is commonly used as an aprotic solvent in various chemical reactions, particularly in organometallic chemistry and Grignard reactions. 5-acetone. Although acetone can participate in hydrogen bonding, it is considered an aprotic solvent because it cannot donate protons. It is widely used in organic synthesis and as a cleaning agent in laboratories. 6-dichloromethane, also known as methylene chloride, it is an aprotic solvent commonly used in organic chemistry for extractions, as a reaction medium, and in various other applications. Protophilic solvents. Protophilic solvents are solvents that have a high affinity for protons, H+ ions. These solvents are capable of accepting or stabilizing protons, making them particularly useful in certain chemical reactions. They are commonly employed in reactions that involve the transfer of protons, such as acid-base reactions and proton transfer processes. Some common examples of protophilic solvents include 1. Water. Water is the most well-known protophilic solvent. It readily accepts protons, making it a crucial component in many chemical reactions, particularly acid-base reactions. 2. Alcohols. Alcohols such as methanol and ethanol can act as protophilic solvents, especially in reactions involving proton transfer. They are often used as solvents in various organic reactions and are important in the synthesis of many organic compounds. 3. Acetic acid. Acetic acid is another protophilic solvent commonly used in various chemical reactions, especially in the synthesis of organic compounds and in the production of various chemicals. 4. Ammonia. Ammonia is a protophilic solvent that is frequently used in various chemical processes, particularly in the synthesis of inorganic and organic compounds. 5. Amines. Amines, such as triethylamine and pyridine, can act as protophilic solvents in certain reactions. They are commonly used as catalysts and as components in various chemical reactions. Protogenic solvents. Protogenic solvents, in contrast to protophilic solvents, are solvents that can donate protons, H+ ions. These solvents are capable of undergoing autoionization, producing protons, which can participate in acid-base reactions. Protogenic solvents are often involved in a variety of chemical reactions, particularly those that involve proton transfer. Some common examples of protogenic solvents include 1. Water. H2O. Water is the most prominent protogenic solvent and is involved in a wide range of chemical reactions. 2 alcohols, alcohols such as methanol, CH3OH, and ethanol, C2H5OH, can donate protons and are thus considered protogenic solvents. They are commonly used in organic synthesis and as reaction media. Carboxylic acids, carboxylic acids such as acetic acid, CH3COOH, and formic acid, HCOOH, are protogenic solvents and are frequently used in various chemical reactions, particularly in the synthesis of organic compounds. 4. Phenols, phenols, which are compounds containing a hydroxyl group bonded to an aromatic hydrocarbon group, can donate protons and are therefore considered protogenic solvents. They are often utilized in organic synthesis and as solvents. Amphiprotic solvents, also known as amphiprotic molecules, are a special class of solvents that can both donate and accept protons, H+ ions. These solvents play a critical role in a variety of chemical reactions, particularly those involving both acid and base properties. They can act as either acids or bases depending on the nature of the chemical species they interact with. Examples of amphiprotic solvents include 1. Water. H2O. Water is the most well-known and commonly used amphiprotic solvent. It can act as both an acid, donating a proton, and a base, accepting a proton, in various chemical reactions, making it essential for many biological and chemical processes. 2. Amino acids. Amino acids, the building blocks of proteins, are also considered amphiprotic molecules. They contain both acidic and basic functional groups, allowing them to donate and accept protons in biochemical reactions. 3. Amphoteric oxides. Certain metal oxides, such as aluminum oxide, Al2O3, and zinc oxide, ZnO, exhibit amphiprotic characteristics. They can react with both acids and bases, making them useful in various chemical and industrial processes. 4. Phosphate salts. Phosphate salts, commonly found in biological systems, are amphiprotic in nature. They can act as both acids and bases, participating in a range of biochemical reactions and processes. 5. Sulfuric acid. H2SO4. Sulfuric acid is an example of an amphiprotic solvent due to its ability to donate or accept protons in various chemical reactions. Joyson Classes. We provide you with valuable and up-to-date knowledge about the pharmacy education. We create entertaining yet informative videos on topics such as chemistry of drugs, biochemical reaction, and much more. Hit that subscribe button and press the bell icon and join our mission to make understanding pharmacy easier for everyone. Like, share, and comment on our videos. We look forward to hearing from you.
Joyson Classes.
The best for best.